Have you ever wondered what would happen if you fell into a black hole? It's a thought that has intrigued and captivated our imaginations for decades. Black holes, these mysterious entities that lurk in the deepest corners of our universe, have been a source of fascination and speculation since their theoretical inception. To understand black holes, we first need to delve into the basics. A black hole is a region of space where gravity pulls so much that even light cannot escape. The gravity is so strong because matter has been squeezed into a tiny space. This can happen when a star is dying, but don't worry, our sun, for instance, is not massive enough to become a black hole. At the center of a black hole, we find a gravitational singularity, a one-dimensional point which contains a huge mass in an infinitely small space. At this point, space and time as we know them come to an end. You could say it's the ultimate point of no return. This concept of singularity is a cornerstone in our understanding of black holes. It defies our classical understanding of physics and catapults us into the realm of the extraordinarily tiny and enormously massive. This is where quantum mechanics and general relativity converge, and where our understanding of the universe is put to the test. Black holes are not just portals to other dimensions or cosmic vacuum cleaners, as often portrayed in science fiction. They are a testament to the power of gravity and the strange, beautiful complexity of our universe. They challenge our perceptions of the known and plunge us into the unknown, daring us to explore and to understand. And while they might seem distant and abstract, remember that our own galaxy, the Milky Way, harbors a supermassive black hole at its heart. So, we are inextricably linked to these cosmic phenomena, these enigmatic giants that silently roam the cosmos. So, black holes are not just figments of a science fiction writer's imagination, but a real and fascinating phenomena in our universe. Now let's tackle some of the biggest misconceptions about black holes. You may have heard that these cosmic entities are like a vacuum cleaner in space, sucking up everything that comes their way, planets, stars, even light. But this isn't exactly true. Black holes do have an intense gravitational pull, but they're not indiscriminately devouring everything in sight. Rather, an object would have to cross the event horizon, the boundary of the black hole from which nothing can escape, to be sucked in. So unless our planet decided to take an ill-advised space voyage, we're safe from being consumed by a black hole. Another popular myth is the idea of black holes as portals to other dimensions or universes. It's a thrilling concept that's been used in countless sci-fi stories, but the reality is a bit less exciting. While the theory of general relativity does allow for the possibility of wormholes, bridges through space-time, there's currently no concrete evidence to support their existence. The extreme conditions inside a black hole would likely destroy anything passing through, making it a less than ideal interdimensional shortcut. Perhaps these myths have persisted because black holes are still shrouded in mystery. They're located thousands of light years away, and by their very nature, they're invisible to the naked eye. This makes them a perfect canvas for our imaginations to paint all sorts of fascinating, if not entirely accurate, pictures. But as our understanding of the universe expands, so does our knowledge of black holes. They may not be cosmic vacuum cleaners or interstellar gateways, but they're still incredibly fascinating. They're regions of space where gravity is so strong that nothing, not even light, can escape. They challenge our understanding of physics, and studying them could unlock the secrets of the universe. As you can see, while black holes are intriguing, they aren't quite the monstrous, planet-devouring beasts some stories make them out to be. So next time you hear a fantastical tale about black holes, remember the reality is just as awe-inspiring, if not more so. So if black holes aren't universe-gobbling monsters, what are they really? Let's dive into the reality of black holes as we understand it today. Black holes are intriguing cosmic bodies that stem from the remnants of massive stars. When these stars have exhausted their nuclear fuel, they undergo a dramatic collapse under the force of gravity, leading to a supernova explosion. What remains is a dense core, and if this core is sufficiently massive, it can form a black hole. Now, the structure of a black hole is as fascinating as its formation. It consists of two main parts, the singularity and the event horizon. The singularity at the very heart of a black hole is a point of infinite density. The laws of physics as we know them cease to function here. Surrounding the singularity is the event horizon, a boundary beyond which nothing, not even light, can escape the gravitational pull of the black hole. It's like the point of no return. But don't be fooled into thinking of black holes as cosmic vacuums. They don't suck up everything in their vicinity. Instead, objects would have to come pretty close to the event horizon to be affected. Now, what role do black holes play in our universe? You might be surprised to learn that they're crucial in galaxy formation. Supermassive black holes, millions to billions times the mass of our Sun, reside at the heart of most galaxies, including our own Milky Way. They influence the orbits of stars in the galaxy, and their intense gravitational pull can trigger the formation of new stars. And here's something even more mind-blowing. Black holes could potentially be sources of energy. You've probably heard of Stephen Hawking's theory of Hawking radiation. In simplistic terms, Hawking proposed that pairs of particles and antiparticles constantly pop in and out of existence near the event horizon. Occasionally one might fall into the black hole while the other escapes, stealing a tiny bit of energy from the black hole in the process. Over an unimaginably long timeline, this could even lead to the evaporation of black holes. However, it's important to note that these concepts are based on our current understanding, which is still evolving. Theoretical physics and advanced telescopes continue to push the boundaries of what we know about these mysterious cosmic entities. The reality of black holes is as fascinating, if not more so, than the myths surrounding them. Black holes, far from being the villains of the cosmos, are crucial elements in the vast cosmic tapestry, influencing the birth of stars and galaxies, and who knows, maybe one day we might even harness their power. But for now, we continue to gaze at these cosmic wonders, captivated by their enigmatic charm and insatiable curiosity. With black holes, there's always more to discover. As we venture deeper into this cosmic frontier, we're constantly developing new technologies and methods to study these cosmic phenomena. One key area of current research is in the field of gravitational waves. These ripples in the fabric of space-time, predicted by Einstein over a century ago, were finally detected in 2016 by LIGO, the Laser Interferometer Gravitational Wave Observatory. The collision of two black holes billions of light years away produced these waves, offering us a new way to study black holes and the universe itself. In addition to gravitational wave research, scientists are also investigating the nature of the event horizon, the point of no return for anything entering a black hole. The Event Horizon Telescope Project, a global network of telescopes, made headlines in 2019 by capturing the first ever image of a black hole's event horizon. This was a major breakthrough, offering us a glimpse into the heart of a black hole, but we're not stopping there. Future research aims to delve deeper, using more advanced technology to better understand these mysterious cosmic entities. One such endeavor is the LISA mission, or Laser Interferometer Space Antenna. This project, led by the European Space Agency, is set to launch in the early 2030s. It will detect gravitational waves from space, providing us with even more detailed information about black holes. Moreover, scientists are also exploring the intriguing possibility of wormholes, hypothetical features of space-time that could potentially be created by black holes. If they do exist, wormholes could revolutionize our understanding of the universe and even provide new avenues for space travel. The exploration of black holes is a journey filled with uncertainty and excitement. Each new discovery, each breakthrough broadens our understanding of the universe and our place within it. As we continue to explore the cosmos, who knows what other secrets black holes will reveal? So we've debunked some myths and dived into the reality of black holes. We've navigated through the fascinating world of these cosmic phenomena, dispelling the Hollywood-induced notion of them as monstrous planet devourers. Instead, we've revealed them as integral parts of our universe's fabric, crucial for understanding gravity and the life cycle of stars. We've journeyed from the edge of a black hole, or the event horizon, all the way to the singularity where space and time become one. Along the way, we've underscored the importance of ongoing research in this field. Scientists worldwide are tirelessly working to unravel more about these mysterious entities, using tools like gravitational wave detectors and telescopes. Stay curious, keep exploring, and join us next time as we unravel another cosmic mystery. Until then, remember, the universe is even more fascinating than we can imagine.